Okay, today I'm going to show you about compound interest. Okay, please note the differences between simple interest and compound interest, especially how we calculate, right, the amount or the balance itself lah. Okay, so first and foremost, right, the principal, okay, is $2,000. Okay, so $2,000, okay, to calculate after 1 year, how much money do I get back if I deposit $2,000? So first, after 1 year, 3% of $2,000, all right, okay, is 0.03 times 2,000. Okay, I'm using the calculator here. Okay, my interest is $60. So my balance after 1 year, if I were to withdraw, is 2060. Okay, compound interest is different in the sense that the principal will change every year. Okay, so now instead of calculating my year 2 interest based on the principal of $2,000, what happens now is this: I use $2,060, then I start to calculate my interest now. Okay, my interest, right, for year 2 is 3%, okay, of 2060. So my interest for this year is $61.80. So my balance in this case is 2060, okay, plus 6180. So my new balance now, new balance, okay, 2121.80. So after year 2, I'll have this amount to withdraw from the bank. Next one, right, is the now my principal is, for the third year calculation, will now be based on 2121.80. You notice how the principal changes, right, every year, as opposed to simple interest where the principal sum is always $2,000. So 2121.80, okay, I calculate 3% of that. I have to pay, or the bank pays me, $63.65. So my new total, alright, okay, 2121.80 plus 63.65, okay, is 2185.45 after year 3. Then for the fourth year and so on and so forth, I get 2185.45. I calculate 3%, and then I can just go on, and you notice that the principal that I calculate my interest changes every year. Okay, now the formula given for compound interest, this formula A, okay, for compound interest, A equals to P times 1 plus R over 100 to the power of N. Alright, okay, A is the amount withdrawn, okay, after, then the principal is the original sum. R, as you know from the other formula, is the rate of interest, and N is the time, okay, in this case number of years. Okay, how does this formula differ? Notice for simple interest, the formula actually gives you the interest, but for compound interest, it gives you the amount withdrawn itself. Okay, let me give you example now. For example, I want to calculate if I put in $2,000, okay. Okay, so now I say for 3 years. If my principal is 2,000, okay, my interest rate, right, is at 3% per annum to the power of N. N is 3 years, okay, for 3 years, alright. Notice that I just key into my calculator 2,000 times 1 plus 3 over 100 to the power of 3. I press calculator, 2185.45. Hey, look, 2185.45. So instead of using all the long steps and calculate one by one, feeding a new principal, using the formula, I can actually get the amount immediately. Then notice, if you want the amount, if you want to get the interest, okay, the interest earned, what I have to do is I have to take this amount withdrawn minus the principal sum, okay, and my total interest that I earn over 3 years will be $185.45. Can? So let me try to do something else now. Okay, why is this formula good? Is because just like the simple interest, sometimes you may have to work with figures like go to 20 years. So for example, if I leave my money in the bank for 20 years, alright, okay, A is equals to 2000, 1 plus 3, that's the interest rate 3% per annum, then to the power of 20. So let's key that into the calculator. 2000, 1 plus 3 over 100 to the power of 20. Ta-da! The amount I earn after 20 years is 3612.22. And remember, for money is correct to 2 decimal places. So this is the total amount I get out. This amount, right, is inclusive of the interest as well. So if I want to get just solely how much interest have I earned, what I must do is I must take my amount withdrawn minus, okay, my original or my principal that I put in the first or the 0th year, and I will earn 1612.22. Can? And that will conclude my discussion or presentation on compound interest.